Rational functions.
A rational function can be defined as a function that is the rational of two polynomials. Rational functions cannot be divided by zero.
Here are some examples of rational functions. The first example is a rational expression because it is a ratio of two polynomials. The second example is also a rational function because the top polynomial is 1. The last example is also an example because it could be written over 1, making it a rational function.
The first example is not a polynomial because a square root of a variable is not allowed. The second example is not a rational function because 1 over x is not allowed in polynomials. The third example is not a rational function because 3 minus 3 equals 0, and rational functions cannot be divided by 0.
Properties in rational functions. A vertical asymptote are vertical lines which correspond to the zeros of the denominator of a rational function. A horizontal asymptote are horizontal lines that the graph of the function approaches as x tends to either positive or negative infinity. Oblique slant asymptotes happen when the polynomial in the numerator is a higher degree than the polynomial in the denominator. The x-intercept and y-intercept are just where the graph crosses the x and y axis.
Now for an example. When finding the vertical asymptote of a rational function, you will set the denominator equal to 0, then solve for x. So for this problem, you'll set x squared minus 9 equal to 0, and that will equal x equals plus or minus 3.
After you find the vertical asymptote, you will next find the horizontal asymptote. To find the horizontal asymptote, if both polynomials are the same degree, you divide the coefficients of the highest degree terms. If n is less than m, then the x-axis is the horizontal asymptote. If n is equal to m, then the horizontal asymptote is the line y equals a over b. If n is greater than m, then there is no horizontal asymptote, there is an oblique asymptote.
Since there are no x's in the numerator, the largest exponent is 0. Therefore, the x-axis will be the horizontal asymptote.
For the equation we have been doing, there is not any oblique asymptotes. However, if you do need to find them, this is how you go about it. You would either divide the numerator by the denominator with either long division or synthetic division. You do not need to finish the long division problem to find the remainder. You only need the terms that will make up the line.
To find the x-intercepts, you just substitute a 0 for the y. In this case, since the equation the numerator is a constant, there will not be any x-intercepts. However, if in any other situation there is, you just set the y equal to 0.
How to find the y-intercepts. To find the y-intercepts, you set the x's in the equation equal to 0.
Next, we'll need some points for the graph. We'll use the following points below. We'll plug -4 in and get 9/7. And then we'll plug -2 in and get -9/5. Then we'll plug 2 in and get -9/5. And then we'll plug in 4 and get 9/7. And then we'll just plot those points on our graph.
Once you plot the points and connect them together, you can see where the vertical asymptotes fall at 3 and -3, along with the horizontal asymptotes at 0. The lines do not touch the x-axis because of this.
Here's an example of how rational functions are used in the business world. Myra takes 2 hours to plant 500 flower bulbs. Francis takes 3 hours to plant 450 flower bulbs. Working together, how long should it take them to plant 1,500 bulbs? Myra will plant about 250 bulbs per hour, and Francis will plant about 150 bulbs per hour, so that added up is equal to 400 bulbs per hour. You then set 400 over 1 hour is equal to 1,500 over t, which is equal to 400 t is equal to 1,500. T then equals 1500 over 400, which is equal to 15 over 4. So take Myra and Francis 3 hours and 45 minutes to plant 1500 bulbs together.